Okay, thank you and good afternoon. So my name is Pierre-Mary. I'm going to talk about some of our plans for laser-driven X-ray sources, and specifically dedicated to non-destructive testing for industry. So it's not a technical presentation, but mostly what our plans and what could be grounds for future collaborations with the panel that is present here. So a quick presentation of Amplitude. So Amplitude has been created in 2001 and has been so far a world leader in ultra-short pulse laser systems. We are present in many, let's say, environments, from the scientific institutions to surgical blocks for eye surgery and to factories in high-tech manufacturing in Asia, for instance. Today we are about 450 employees. Our headquarters is based in Bordeaux in France, with more than 5,000 square meters of production area and let's say several hundred thousands of lasers installed in the field today. We can share our market or our applications into three different types. The scientific part, which is an important topic for Amplitude, and I'm in charge of this part in Amplitude, with different type of applications and different type of technology. We'll see it a bit later. The industrial applications, where we address what we call real-world applications with displays, semiconductors, and consumer electronics and microprocessing, and medical applications with some very prospective work on proton therapy and X-ray imaging, but also some very big market applications like ophthalmology. There is a strong synergy between our scientific business and our industrial business. This has been the strategy of Amplitude since the beginning, saying that we explore new applications using less laser solutions, so not necessarily product, but we're looking for flexible solutions that can address different type of applications and with different kind of parameters, laser parameters, in order to be able to change them and find the right parameters for an application. And once we have done that, we switch to the exploitation of this application using a more product-oriented technology. For instance, Amplitude, this is a diode pump ytterbium lasers. And this has been done since the beginning of Amplitude, and especially starting in 2007, where you could see the evolution of our product range and addressing the markets. So from ophthalmology in 2007 to the new application that we are looking for today, we are chasing more today. And we can give as an example aeronautics, metallurgy, and battery applications, which require very high power laser, up to kilowatts. And we have very ambitious programs in this field. So what are we exploring in the scientific part, and always keeping in mind that our ultimate goal is definitely to use this exploration work to definitely address some industrial or medical applications. So the secondary sources, here we are talking mostly about TISAF, ytterbium high energy systems. So we are combining high energy and high repetition rate or high average power laser systems in the gigawatt range, developing UV, visible and mid-IR sources or terahertz sources. In the terawatt range, so LPP, so laser produced plasma, X-ray sources, and ICS sources. And for the particles, using very intense laser to generate giga electron sources or proton sources. What is very exciting right now for the secondary sources is to benefit from the laser wake field acceleration, and we call it a revolution because there are a lot of work around laser wake field acceleration, electron laser wake field acceleration right now, because using intense laser femtosecond laser focused into a gas target, we can generate very high energy electrons, and with a gradient which are much higher than in the conventional accelerators. This provides a compact source of accelerator that can be used later on to generate radiations. Converting the electrons into X-rays can be done in many different ways. You can see here the Betrachon, Bremsstrahlung, and inverse quantum scattering. So giving each time different sources parameters. So depending on the usage of the sources, one can use one or the other. As you can see, there are different photon spectra, different energy range, the energy range defining the penetration depth of the X-ray, and there are also different source sizes. The source size defining mainly the resolution of the source. And if we compare the existing technology today, what we can see is that for LPP, Betatron, and Bremsstrahlung, to be able to compete or to compare with synchrotron sources or ICS sources, one needs to definitely increase the flux. So the key parameters are energy and brilliance. And to increase the brilliance, today Amplitude is working using its core technology. So TISAF, Ytterbium, and now OPCPA, because we have acquired Fastlight, the French company, to increase our repetition rate while keeping the high energy laser systems working. So one of the first, let's say, target or application that we are looking in partnership with several actors is the non-destructive testing. While it is done for many decades with using ultrasonic processes, using radiographic, using lasers is very promising. And there's a lot of work around that. And the key parameter is the radiation source size that will give a very high resolution compared to existing technologies. There are different ways of doing that. So either you doing using the X-rays or for the neutrons. The existing, I would say, conventional technology has obviously a lot of advantage today, but none of them are totally, let's say, sufficient to do everything. So you have different different complementary technologies, and we believe that the laser-based secondary sources could have a place with its spot size for a few microns and significant penetration depth. For instance, the micro CT, so micro computed tomography, so precision tomography, is we have the motivation to detect a very small defect on the object that we are scanning or analyzing. So definitely our target applications are in the batteries industry or additive manufacturing or electronics industries. Here, this is an example that you can find in the literature of composite analysis on different type of object using NDT processes. So I'm not going to comment too much on that. These are things that you can find online. And this is here an example of at Gemini using a 7 joule 50 femtosecond at 3 shots a minute. And with 10 shots, you can see that we can make a quite nice radiography of pouch cell battery, and also detect some material defect on the right side. And I went quite fast. Okay. As a conclusion, so synchrotron experts have opened the way to new modalities for industrial applications. So now there is a growing need for quality control using X-rays, and which require very high precision and fast scanning. With the improving our laser technology, we can open the way to using our secondary sources to do so. Obviously, industrial and medical applications could benefit from this, from the increasing average power. We will, and other technology, we also make a big progress as well. And now to answer the question, so what can you do for us and what can we do for you? I think that we have right now some ongoing R&D project, but we are always, let's say, open to new collaboration in this field. So generating secondary sources and different types of secondary sources and study them, and developing the laser technology enabled to complete the studies, and definitely trying to push this into industrial applications. Thank you.